Greetings. I'm going to do a short video with you on magnets, which we just mentioned in the last class. And I'm going to title this video, Fun with Magnets. So I'm going to start off by showing you some interesting things about magnets. And one of them is this fun toy here called the buckyballs. What these are little spherical magnets that you can actually stretch out, make all one strand. See if I can do that. Or you can actually play with them almost like clay. They're pretty fun to work with. And I'm going to make myself a little necklace here out of buckyballs. There we go. So this is magnets. They have a north and a south pole. The north pole of one is attracted to the south pole of another. And one of the things about magnets that makes them special is that you can never have just a single north pole or a single south pole. That's unlike electric charges where you can have a single positive or a single negative charge. In magnets, there's no such thing. Yeah, so it's called a magnetic monopole. We've been looking for one for centuries, have not seen it. And I don't think we will. Although sometimes you'll read about them, but you won't see one. So there's another little demonstration I'd like to show you if you use buckyballs. I'll use these other spherical magnets. I'm going to move my new camera that I got from Best Buy. Miguel helped me buy it. And I'm going to run these two spherical magnets together. Hope you can see it. Try it again. That's great. So what happens is one of these is rolling one direction, the other is rolling the other direction. As they come closer, they start to attract each other. They come together, and all that energy of motion, because there's a force pulling in the opposite direction, it causes them to spin. And so the pair of them starts spinning. It's just one of those great spherical magnetic demonstrations that you can do. Really like that one. Spherical magnets. These are also called rare earth magnets. Because they're so strong. They're made out of neodymium, and there's a special formulation of metals that are melted together to create a very strong, an element with a compound basically with a very strong magnetic field. And going on from that, there's actually three types of magnetism. And I mentioned this in class the other day. There's ferromagnetism. These are the strong magnets that you can use or that you can place on your refrigerator, for instance. Those are examples of ferromagnets. And here's some other rare earth magnets that are quite strong. Matter of fact, I could pinch myself by putting my finger in between them. It could be very painful. Don't want to do it, but you can see the magnetic field is going right through my finger. That doesn't hurt, but if there was too narrow a piece of skin and they were coming too quickly, it could pinch, as you can imagine. Ferromagnets, one example of that is that. Whoop! I just did this. I just landed them into my iron filings. They'll never come off, all of them. There'll always be some now on them. They're really hard to get off. Anyway, I'll show you the iron filings in just a minute. Another type of magnetism is paramagnetism, which is kind of a weak form of magnetism that many elements exhibit some degree of paramagnetism. It's a much weaker magnetism than ferromagnetism, so there'd be a weak attraction between, say, a strong magnet like this and some elements such as aluminum and other materials. Oxygen's another example of an element that exhibits paramagnetism. Iron oxide also exhibits paramagnetism. It's not as strong as just plain ferromagnetism, but there is some weak attraction. Very weak. Then there's diamagnetism, which is the third one on my list. This is associated with substances that do not allow magnetic fields to penetrate them. And I mentioned in class that one example of that is a superconductor. So you can actually get superconductors, and you can, if you put a magnet near it, you can actually make the magnet levitate, because the superconductor won't let the magnet fall on it. The magnet actually levitates on top of it, and it's kind of floating there. You can actually buy a kit to do that. I'm going to show you an example of an application similar to that using the element bismuth, which is also diamagnetic, not as strong as a superconductor. But as a result of using bismuth, we can create what appears to be, well, it is levitation. And this is the example of it right here. Between these two plates, one of which, the upper one is, I think they're both bismuth actually, the magnetic field is stable. So if I didn't have the bismuth there, that little magnet that's floating, it's a rare earth magnet in the middle that's floating, would go either up or down. It would either be attracted or repelled. It wouldn't have that sort of stable zone in the middle. But having the diamagnetic substance of bismuth there allows that to take place. And I can adjust where the stable zone is by adjusting the height of the magnet. If I pull the magnet further away, the stable zone actually gets lower. If I make the magnet closer, as I'm showing you here, the stable zone actually gets higher up. You can see what's happening to the little object in there. We could talk more about that, but my point here is to make that diamagnetic substances repel magnetic fields, and they allow phenomena like this to occur. I want to now use iron filings, as I mentioned a few minutes ago, to show you what you can do with magnetic fields. So what I'm going to do is this. I'm going to rearrange my camera, and I am going to place this bar magnet right here underneath this lid. North is this way, south is that way. A lot of the bar magnets are labeled. I'll cover it with a plastic container. And then I'm going to sprinkle some iron filings on top of it. You can actually see, I'm not going to put too many on because it'll make the phenomenon harder to see, but you can actually see they're kind of lining up, almost like those electric fields that you had to sketch for earlier. Magnetic fields actually show similar, they look similar in terms of their shape. There's field lines that look kind of like a dipole. It actually is a dipole. You have a north pole and a south pole. You can't have one alone, but they always come in pairs, unlike electric fields. You can have a north pole and a south pole for a magnet. And you can see the the magnetic field lines that are created by this magnet here, this bar magnet. You can actually see that they're three-dimensional. We'll talk more about magnetic field lines later, but I want to show you that you can see them by using iron filings to kind of trace them out. I'm going to make it more obvious that they're three-dimensional right now by putting a much stronger magnet underneath. I'm going to use ferromagnet, which is this one here. Get rid of this guy. This one here. And it just pulls those iron filings so strongly that it actually supports the ferromagnet underneath it. It's actually being held here by the attraction to these pieces of iron there. And you can see it's also a three-dimensional phenomenon. Set that back down. I'll sprinkle more on here. It's like almost a little animal or something. Those field lines are in that three-dimensional shape that you see them taking as a result of this magnet beneath the plastic plate there. Okay, so that is an example of looking at magnetic field lines using the iron filings associated with a magnet. If I pull the magnet away, field lines go away, as you can see. The last thing I'm going to show you is a piece of lodestone. Lodestone, as I mentioned in class, I believe, is one of the first magnets seen in nature. I think the first record of this is in China a couple thousand years ago, where they noticed that certain stones would attract other pieces of iron containing substances. So it's so weak, it's actually hard to feel much attraction. If I put it near something iron like these iron filings, I can feel a weak attraction, nowhere near as strong as these rare earth magnets. They'll stick to it like that. They're really strong. But there are still field lines, and I'm going to show you by sprinkling some iron filings on top of here. You can still see evidence of some magnetic fields associated with this piece of lodestone. There's a little bit of structure there, three-dimensional structure. We'll move this away or put it there. Let's see if I can show you a little bit more of that. Very weak structure there, but there's a little bit. You can see some lines forming where the iron filings are trying to follow the magnetic field lines associated with the lodestone. Great. So many fun things we can do with magnets. And I'm going to see if there's anything else I want to show you before I end this video. Probably, but I'm going to wait till the next video. Okay? So that's the end of the first video on fun with magnets.